All right, so this is a short video on how to set up the bump box using a single solid state relay. This diagram you're looking at, my girlfriend was kind enough to draw up for me. This is about the easiest way that I've come up with to use the bump box through Holley. I'm going to go through the setup procedures on it in a minute, but I just wanted to let you guys see the the schematic for it, how simple it is, and I'll also post a picture of it with this post. But we'll come back to this here in a second, but I'll refer back to this as we go through it in the actual setup of it. So here's what we're working with. You go into your software. We'll do the software first, and then we'll talk more about the wiring. So you go into your software, and what you're going to do is you're going to create an input. So you should already have your input-output ICF enabled, and then you're going to create an output. So the output that we're going to create here is this bump button output. So this one right here, number 7 on this global folder. We're going to make it a 20 volt output or input, and then we'll pin map it in a second. But you want to enable it. You can check configure. There's nothing to configure with it, but it's just a force of habit. You always look at it. You're also going to have to create an output. So I call it just bump or bump out, whatever you want to call it. It has to be pulse width modulation negative. Again, we'll pin map it here in a second, or we'll go through pin mapping it in a second. Enable it, and then click configure. This is where you have to actually do a little bit of programming with it. So you're gonna, normally this would pop up and it'll say 0 switched input triggers. We're gonna change it to 1, and this output will activate when the trans brake is enabled. If you look back at the diagram, you'll understand that what we're doing is we are interrupting this solid state relay. So when the bump button is not pressed, you've got 12 volt going through the solid state relay and down to your trans brake solenoid. All this is going to do is it's going to pulse this relay. And I'm going to show you now kind of how to set that up. So you've got your trans brake enabled for your switched input trigger. There's nothing to do here, nothing to do here, just pulse width modulation setup. Now this table was for my personal stuff. This was a Turbo 400 and a pretty loose converter. So these numbers here in red, you'll have to tune yourself. With a Power Glide, I found, it was actually quite drastically different from a Turbo 400 in this converter. But the tighter the converter, the higher this number is going to be. So let's start from the beginning. I'm going to go to type fixed instead of RPM derived. Frequency, I found, seems to work best between 15 and 18. You want to change the table units to duty cycle. Okay. You can do this. You can make your x-axis either RPM or boost. In my setup, if we moved RPM, boost followed, it was very dead on. Some people may want to change this to boost instead of RPM, but your y-axis is going to be your bump button. Okay, so that was your your input was your bump button. So on the left-hand side, you're going to see voltage. Okay, so remember we made a 0 to 20 volt input. The reason this here, when it sees less than 9.3 volts, it stays 100%. That's how it keeps that solenoid or that solid state relay functioning no matter what the RPM range was. Okay, so the trans brake functions like normal. You hold the trans brake down, and then when you press the button, it will bump, which in turn is actually making that solid state relay go from 100% duty cycle to, in my application, 63%. So The further down you come, the more violent the bump will be. Putting this at like 95 is not going to let the car even move. The bump button won't function at all. I found with a Power Glide, I started somewhere in the neighborhood of 75 when it was down in low RPM, lower power, and then at higher power, you'd want to increase your number here for duty cycle. So you want to get it closer to not functioning. Basically 100%, it's kind of backwards, but 100% is you're not pulsing it at all. And then 80%, you're really only pulsing it like 20%. That's kind of the way I've always thought of it. And it's the way it makes sense to me. This setup right here was extremely smooth. This was a hold the button down and it would slide into the beams without having to hold the foot brake or doing anything fancy. You literally just hold the button down and it would slide straight into the second bulb. No rocking, no crazy carrying on. Anybody that's seen our car run can attest to it. It's always been the smoothest entering at everything you see else at the racetrack. No more jumping around or banging. So this will be something that you have to kind of play with. If you set this up and you hold the trans brake down and you're at, say, 4,000 RPM and 10 pounds boost, and this thing is jumping, wants to jump through your garage, right? Well, you know at 4,100 it's going to be worse. So we'll take this number and we will we'll just start going up. So we'll try 69.4 instead of 63. And as you go up, it'll soften it, okay? So if it's not moving at all, you have to come down. I know I just made some drastic swings there, but I probably wouldn't get too drastic. I would go maybe 2 numbers out of shot, tops. And the closer you get to the converter actually, I guess, tugging down on the engine real hard, the closer you're going to want to be to 100%. So turbo 400 with a 148 first gear and a 373 rear gear was very soft, so it needed a good bit of duty cycle to get it to move. But again, this will be something that you're going to have to play with. Again, somewhere in the neighborhood of, with the Power Glide, I would start about 75 to 80. Turbo 400 with a 148, well, second gear, which is your gear that you're going to leave in, I would start somewhere around 65, and just, play with it as you go. The cool thing about this is if you go to a track that you can't leave on more than 3,900 RPM and however much boost, you can have this number say whatever you want, and you can have this number go up. So if you know you're going to make, if it picks up an extra 200 horsepower going from 3,900 to 4,200, you know that you don't want the car to start getting violent and jumping at 4,200 when it's smooth at 39. So smooth this table out. Sorry about all the Facebook updates here, but anyway, now that you have this built, you're going to have to pin map it, okay? So there's a lot of stuff here in this pin map, but the first thing that you're going to need to find is your bump button, right? So if this is the way it would look when you just got done doing it, disregard the rest of this stuff. But the bump button, see it's got a 2 there, just click it and drag it to the input that you have it wired to. Output, same deal. So you're going to look for, it'll be a P with a minus. So just click it, drag it to wherever you had it, and and you're done. Now we'll go and look at the wiring here. So starting from the battery, I didn't draw in a fuse or anything like that. I mean, just use common sense. Power into one side of the bump button, which, put it on the steering wheel or whatever. And then out of the other side of the bump button, it's going to come out of there and go into the input that you picked in your pin map on the ECU. For the trans brake circuit, power out of the battery into one side of the trans brake button. Out of the other side, what you do is you take the orange wire off the solid state relay, and the relay I'm referencing is this one. It's the Holley high current nitrous solenoid driver, 554-111. Honestly, for the money, you're getting a nice solid piece that's got some heavy gauge wire to it, so you don't have to worry about, upsizing wire or anything, or those ghetto like hella relays where you have to crimp some ugly spade terminal on it and then hope that you can shove a 12 gauge wire in there and it doesn't fall off and rattle apart. This thing's nice, it's sealed, it's got a little mounting flange on it. I usually drill 2 holes over here and just nut and bolt it to whatever on the firewall or something. But this is the solenoid that I'm referencing. So as you can see here in this little picture, the wire colors that I'm referencing also, blue, orange, black. All right, so we'll go back to this. So the trans brake button, you've got power coming in, grab the orange wire off the solid state relay, hook it to the other side of the trans brake button. The heavy blue wire, which is going to be longer, it's almost like they thought of this and made it for this. This blue wire is like 8 foot long or something, and it's plenty long enough to make it all the way down to your trans brake solenoid. You're going to hook that up to the positive side of the trans brake solenoid, not the negative. Now, the only other wire that you have to deal with is the solid state relay's black and yellow wire. It's already comes terminated with a pin for the ECU, which makes it easy. If it's too long, cut it down, crimp your own pin on it. But you're going to run that to your pulse width modulation negative output that you picked in your pin map on the ECU. I think that's about the easiest way to do a bump box with Holley, and it makes it pretty infinitely adjustable also. Hope this helped some of you. Have a good one.